And let's take a look at section 3.2. Next week is the midterm. So if you haven't started studying for it, probably be good to study for it because it's comprehensive up to that point. It'll include everything from chapter 1 and chapter 2, basically. Now, section 3.2 is polynomial functions and their graphs. We'll have the next week is the midterm, but specifically which day we'll have it is on Wednesday. So if you're wondering. Now we're going to review a little bit. Well, you go back even one more. Variable is a single letter, of course. Usually represents an unknown value. Oh, and don't sit next to each other. A little bit more, 6 feet. Yeah, I'm not gonna have the president of college come by and see me and say, oh, he's not keeping people 6 feet apart. Now term is a number, a variable. You can have more than one, or a number times a variable. Example, you could have like 5. That would be a term. 7x would be a term, a number times a variable. X squared would be kind of term. When I say variables, I'm talking about x times x. So I'm talking about multiplication. And that's what this would be, variables. Or you could have like 8x to the third. Number times variables. So 8 times x times x times x. So that's a real informal definition of what a term is. Now, if you have one term, it's called a monomial. If you got 2 terms, it's called a binomial. If you got 3 terms, it's trinomial. And specifically, what we're looking at in this section, polynomial functions. That's one or more terms. So that's a generic definition, covers all of them. So a monomial would be a polynomial, a binomial would be a polynomial, so forth. Now we have something called standard form. This is when your terms are arranged, and it can go either way, but I'm going to say terms are arranged from largest power down to smallest power. Some books will indicate standard form can go from the smallest power up to the largest power, but they're in order. We have something called degree, which is our largest power of x. It's a little bit more than that if you have like two variables, like x and y. But for this class, we just pretty well just deal with one variable. So that's your largest power of x. Now these first problems says identify which functions are polynomial functions. For those are identify the degree. Now a real again informal way to determine something's a polynomial or not is with this stipulation. Note polynomials cannot have variables in the denominator, negative powers, or fractional powers. Now, the number of items that a polynomial cannot have, those are the three most common ones you see in problems. We're going to see graph-wise, there's some things it can't have too here shortly. When I look at this one, I'm going to use my informal rules for it. There's no variables in the denominator, no negative powers, no fractional powers. This would be a polynomial. And the degree is the largest power of x, which would be 3. So the answer there is yes, and then 3. Now this one, I notice that it has a variable in the denominator. You can't have that. So the answer is no, it's not a polynomial function. If it's not a polynomial function, it doesn't have a degree. This is actually a rational function, which we'll see later on in this chapter. Rational function means single fraction variable in denominator. And specifically, variable in denominator is the main focus. You might say, well, that's not a single fraction. Well, we couldn't rewrite it, put each one of these over 1, get a common denominator. We could rewrite it as a single fraction. But anyway, no, it's not a polynomial, it's no degree. Now this one has a fractional power. And I said we can't have a fractional power. Fractional power actually indicates a radical. So the answer is this polynomial, the answer is no on that. And since it's not a polynomial, it doesn't have a degree. Now this one has a denominator, but specifically I say you cannot have a variable in the denominator. Other than that, this doesn't have any of the bad items, so this would be a polynomial. The answer is yes here. And your degree is your largest power of x, which would be 2. Now graph-wise, polynomials cannot have sharp corners. Hey, you got a sharp corner, you still start moving it out, and at some point it'll become a line, and the line is a polynomial. But just in general, it can't have sharp corners. Can't have gaps. And can't have holes. On number 5 here, where it's asking us to identify which graphs are not those of polynomial functions, you notice we got a sharp corner here. That's actually an absolute value. That's what causes that sharp corner like that. So the answer here is no, it's not a polynomial function. One author I read and for a college algebra textbook, it described it as if you can go to one end and go to the other end, drawing nice loopity loops, then that's a polynomial. Not quite true because a line is a polynomial. And also, if you've taken any trig in a previous class, sine and cosine are nice loopity loops going across the page. But it's just a very informal way of thinking of it. The answer on this one is this polynomial, yes. Nice loopity loops going across the page. I don't have any holes, don't have any gaps. Now this problem would not be a polynomial because you notice I have a gap right here. So if you have a gap, it's not a polynomial. So the answer here is no. This is actually a rational function. That's what causes that to occur. Now, the one example I don't have of this is a hole. Hole is where your graph is going across, and there's a hole in it. It would look like that. So that would not be a polynomial because of the hole. This next problem is going to talk about the leading coefficient test. Leading coefficient test is a technique to help us graph polynomials. The technique really focuses on what's happening to the far left and far right. We have something called our leading term. This is the first term when the polynomial is in standard form. Then we have a leading coefficient. This is the coefficient of the leading term. Number in front of the x to a power. If you forgot what a coefficient is. Remember, a degree is our largest power of x. Now for this coefficient, I'm going to refer to it just as COEFF. So when I put that, I'm just talking about, not talking just about any coefficient, I'm talking about leading coefficient. Now, we can either have an even degree or you can have an odd degree. You can have a positive coefficient or you can have a negative coefficient. Example of a positive coefficient, even degree, that's y is equal to x squared. And if you think about what y equals x squared looks like, it's going up to the left, up to the right. And that's what it's describing. It's describing what is it doing clear to the right, what's it doing clear to the left. Now, if you got an odd degree and a positive coefficient, like y is equal to x to the third, it's down to the left, up to the right. If you got an even degree negative coefficient, it's down to the left, down to the right. And if you got an odd degree and negative coefficient, then it's up to the left, down to the right. Now this one, number 8, says use the leading coefficient test to determine the end behavior of the graph, then match the graphs below. Let's see if anybody had a question. I think that maybe was out in the hallway somewhere. Okay, so this one we got f of x equals x to the third minus 4x squared plus x plus 2. It's in standard form. Terms range from largest power down to smallest. My leading term is the x to the third. The leading coefficient is the number that's in front of that, which is a 1. So we got a positive coefficient. Our degree is 3, largest power of x. So degree is odd. Now you look at the intersection of these. The intersection that tells us that our graph should be down to the left, up to the right. So as I look here, I'm looking for a graph that's down to the left, up to the right. That's up to the left, down to the right, up to the left, up to the right, down to the left, down to the right. This is the one that's down to the left, up to the right. So down to the left, up to the right is B. So matches that one. Now it doesn't tell us anything about what's happening in the middle. All it's telling us is what's it doing clear to the left, what's it doing clear to the right. That's what the leading coefficient test tells you. Now number 9 says use leading coefficient test to determine the end behavior of the graph of the polynomial function. Now this is in standard form. Terms range from largest power down to smallest. So our leading term is negative 5x to the third. My leading coefficient, or just called coefficient, is negative 5, which is negative. So we got a negative coefficient. Our degree, largest power of x, is 3, which is odd. So we got an odd degree. And I'll look at the intersection of these, and that tells me that my answer, because all they're asking for is use leading coefficient test to determine the end behavior. Our answer is up to the left, down to the right. This is used a little bit in graphing. If you were to graph that, and let's say your graphing calculator showed this. Well, if we indicate it should be up to the left, down to the right, what that means, down to the right means this can't be going up. So at some point in time, it must turn back around so it can go down. That would tell you that you're not seeing all of your graph on your graphing calculator. If you're going on business calc, that means you need to zoom out in order to see more of your graph. Pretty much in this class, I'm happy with just your standard display. I'm not even really showing the zoom. Not unless we have time at the end. Now this next problem covers some different definitions, and I like to do it by example, so I'm going to work this problem. For 10. Got this function, and first thing it says find the zeros for each polynomial function. Our technique for finding zeros is always the same. You take your function, and you set equal to 0 and solve. That's how you find zeros. Now zeros are where it crosses the x-axis. Now, typically how we would solve these is, of course, you have to get 0 on one side, which we've seen back in chapter 1, but that's by default, it'll be that way. Then the other way is to then factor the other side. Well, this is already factored. Remember we had the 0 factor property? You get 0 on one side, you factor the other side, you say these factor equal to 0. So I said 2 equal to 0, x minus 3 equal to 0, x plus 1 equals 0. Now we're solving for a variable. You never need to set a number equal to 0. We saw that back in chapter 1. This one gives us x equals 3 and x equals -1. And these would be our zeros. Now it says, find the zeros for each polynomial function, give the multiplicity of each zero. There's a clever movie called Multiplicity. It's comedy about an individual that made a clone of himself because he wasn't having enough time to play, so he made a clone of himself so the clone would go off to work. And so he played golf and have fun all day. And then his wife got a job or got a career promotion. And so he had to take care of the kids and do stuff around the house. And he didn't want to do that, so he had another clone made of himself. And then the clones got tired of doing their own work, so they made a clone of themselves. Humorous movie. It's called Multiplicity. Multiplicity refers to how many do you have. Now, your power will tell you that. For our x plus 1 that we solved, it had the second power, which means my multiplicity of the -1 is 2. The x minus 3, if I were to put a power on it, would be the invisible 1. So it has a multiplicity of 1. Then the last thing in this problem it wants to find, it says state whether the graph crosses the x-axis or touches the x-axis and turns around at each 0. So we're looking whether it crosses or touches. And if you got an even power, like the second power, fourth power, sixth power, what you're going to see, it comes down and touches or goes up and touches at a point and then turns around. So this would be a touches. This is a 1, so that crosses. Whenever it has a multiplicity 1, then it crosses. We're going to use that fact when we're solving problems later on in this chapter. In terms of graphing, what that would tell us. So I had -1 here and 3 here. This would be going down, this would be going up from our leading coefficient test, if I were to look at that. And it crosses here. Scroll up. -1. Touches here. So it touches here, crosses here. So if I know it's going down here, then my graph's going down, of course, there. It's coming up. If it touches, it comes up, touches at a point, turns back around. Then at some point it has to turn back around because it has to come up here to cross. So the leading coefficient test plus the touching and crossing tells us generally what the graph looks like. What I don't know is I don't know how far this goes down. So I'd have to plug in x equals 1 into my original function to try to understand a little bit better of how far it goes down. Now we're just going to be examining the multiplicity and touching and understanding touching and crossing. Any problem dealing with graphing, I just want you to plug in your calculator. It is important later on, like I indicated, because if it touches, that means the answer repeats. and we'll see that. Okay, number 11. Got f of x is equal to x to the third plus 3x squared minus 4x minus 12. Same instructions. First thing we want to do is we want to find the zeros. So, let's set equal to 0. And then solve this. Well, this factors by grouping, because we have 4 more terms. Group first 2 terms together, group last 2 terms together. These have an x squared in common, leaves me x plus 3. These have a negative 4 in common, that leaves me x plus 3. They both have an x plus 3, so I factor that out. And that leaves us x squared minus 4. We then can use difference through squares, the x squared minus 4. That factors as x plus 2, x minus 2. Zero factor property. You get 0 on one side, you factor the other side, you set each factor equal to 0. So x plus 3 equals 0, x plus 2 equals 0, x minus 2 equals 0. So we get negative 3, negative 2, positive 2. And those would be our zeros. Now they also want us to find our multiplicity. And none of these have powers, but if we were to put a power on them, it'd all be the first power. There's an implied 1 if there isn't a power. So multiplicity of all these would be 1. Now touching and crossing, since they all have odd multiplicities, that means that these cross. If I was graphing this, negative 3, be a 0 there, so I know there's a point there. Negative 2, there's a 0 there, so I know there'd be a point there. Positive 2, I'd know there'd be a point here. If I use my leading coefficient test, I got a leading term of x to the third, so it's a positive coefficient, odd degree, which means down to the left, up to the right. All of these are crossing. So if this is down to the left, I know it's going down as it goes to the left. Has to cross here. At some point in time, it has to turn back around because that's come back down here to cross. And at some point in time, it has to turn back around here because I know it has crossed there. Again, what I don't know is I don't know how far up this goes. I don't know how far down this goes. If I was doing this by hand, I'd have to plot some points. Like I'd try maybe x equals negative 2.5. That'd be what looks like halfway in between these numbers. X equals 0 probably be a good one. That'd be, it looks like halfway in between these. That'd tell me how far down it goes. And the alternative on this is if you didn't use these techniques, you just had to plot a bunch of points in the t-chart and then plot those. It still probably wouldn't be good. So again, these save you time if you do it by hand. Now, last problem's asking us to graph this. So I'm just going to use a calculator. Just to get one example of that. Okay, so graph that. That's my y equals clear x to the fourth plus x to the third minus 6x squared, and then press graph. Now, if I were to find the zeros on this, let me show you how that compares in the touching and crossing and so forth. Okay, so x to the fourth plus x to the third minus 6x squared equals 0. Factor out an x squared, and that leaves me x squared plus x minus 6. That's GCF. PSD, this factors as x plus 3, x minus 2. Zero factor property, you get 0 one side, you factor this side, so each factor equals 0. So I have x equals 0, x plus 3 equal to 0, and x minus 2 equals 0. You get 0, negative 3, and positive 2. 0, negative 3, positive 2. That's where it touches or crosses the x-axis. Our multiplicity. The power on this is a 2, power on that's a 1, power on that's a 1. And then our touching and crossing, we said if we have an even, it touches. If we have an odd, it crosses. And you notice that x equals 0, it comes up, touches at a point, and turns back around and goes back down. So that goes hand in hand with what we said that the graph should do. Questions on finding zeros, multiplicity, touching, crossing? Well, we're done with 3.2, so let's take a look at 3.3. This is dividing polynomials, the remainder, and factor theorem. And let's take a look at our first problem. Most of this should just be review. Let's see, x minus 4, x squared plus 2x minus 24. And it says divide using long division. Some books call it polynomial division. Now, when you're doing long division, you take a look at the first term of each, decide what goes up on top. you ask yourself, what times x gives you x squared? And that'd be x. Now, whatever you put up on top, you're going to multiply by what's out in front. So we take x times x minus 4. X times x is x squared. X times negative 4 is negative 4x. And that's x squared minus 4x. Then we're going to subtract this line, which means you flip signs. This positive x squared becomes a negative. This negative 4x becomes a positive 4x. A lot of people do that step in their head, but since I can't show you steps in my head, I write it out, circle it like that. X squared minus x squared. 2x minus a negative 4x. Again, the negative becomes positive, so we got 2x plus 4x is 6x. And then depending upon who taught you division, you either bring down what you need or you bring down everything. I was taught to bring everything down and think of it as a brand new problem. Again, I look at the first term of each side, what goes up on top. I ask myself, what times x gives me 6x? And that'd be 6. Just like before, whatever you put up on top, you're going to multiply by what's out in front. So I'll take 6 times x minus 4. 6 times x is 6x. 6 times negative 4 is negative 24. I'm going to subtract that line, which means flip signs. So the 6x becomes negative. The negative 24 becomes positive. 6x minus 6x drops away. Negative 24 plus 24 gives us 0. So our answer to this problem would be x plus 6. Let's take a look at this problem. Okay. We take a look at the first term. Decide what goes up on top. You ask yourself, what times x gives you 2x to the third? And that'd be 2x squared. Whatever you put up on top, you're going to multiply by what's out in front. So I'll take 2x squared times x minus 2. That gives us 2x to the third minus 4x squared. Now I'm going to subtract that line, which means flip signs. So this becomes a negative, this becomes a positive. 2x to the third minus 2x to the third drops away. Negative 10x squared plus 4x squared is negative 6x squared. Then I'll bring down everything else. Again, we look at the first term of each to decide what goes up on top. You ask yourself, what times x gives you negative 6x squared? And that'd be a negative 6x. Whatever you put up on top, you multiply by what's out in front. So take negative 6x times x minus 2. Gives us negative 6x squared plus 12x. I'm going to subtract that line, which means flip signs. So this becomes a positive, this becomes a negative. If 6x squared plus 6x squared drops away, negative 3x minus 12x is negative 15x. Now bring down to plus 1. and we repeat. Again, we look at the first term of each side, what goes up on top, ask ourselves what times x gives us negative 15x, and that'd be negative 15. Whatever you put up on top, you multiply by what's out in front. So I'm going to take that negative 15 times the x minus 2. And that gives us negative 15x plus 30. I'm going to subtract that line, which means flip sign. So it becomes a positive. This becomes a negative. Negative 15x plus 15x cancels. 1 minus 30 is negative 29. Negative 6x squared, negative 6x squared, plus 12x, okay, minus, I guess negative 15x. For some reason, I was thinking that's going to be 31. Well, we take our remainder and we put over what we're dividing by. Because there's nothing times x that give you negative 29. Actually, when the degree of this becomes less than this, that's your remainder. So yeah, that's our answer right there. Questions on that problem? Okay, number 3. So third minus 2. X to the 5th. Minus 3x to the 4th. Plus 5x to the 3rd. Plus x squared. Now, 2 things have to be true for you to use long division, polynomial division. First thing, it must be in standard form. Now, these 2 are in standard form, so we're good there. Second thing is we're going to put 0 placeholders for missing powers. So we're going to put 0 placeholders for missing powers. For example, this x to the 3rd minus 2 is missing the x squared and it's missing the x. So out in front, I'm going to put x to the 3rd plus 0x squared plus 0x minus 2. Inside here, x to the 5th, x to the 4th, x to the 3rd, x squared. We're missing the x and we're missing the no x, the constant term. So I'm going to have x to the 5th minus 3x to the 4th plus 5x to the 3rd plus x squared plus 0x plus 0. So again, have to have these in order, largest power down to smallest. And for any missing powers, you put your 0 placeholders. Some people teach leaving spaces. From there, I'm going to do what I did in the previous examples. Take a look at the first term of each. Yeah, ask yourself, what times x to the 3rd gives you x to the fifth, which would be x squared. Then whatever you put up on top, you're going to multiply by what's out in front. X squared times x to the third is x to the fifth. X squared times 0x squared is 0x to the fourth. X squared times 0x is 0x to the third. X squared times negative 2 is negative 2x squared. Flip sign, because we're going to subtract that. That becomes negative, 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 positive. When you put 0 placeholders, you put everything in standard form, you make sure that all the columns line up with like terms. X to the fifths, x to the fourths, x to the thirds, x squared, so forth. Okay, x to the fifth minus x to the fifth drops away. Negative 3x to the fourth minus 0x to the fourth is negative 3x to the fourth. 5x to the third minus 0x to the third is 5x to the third. X squared plus 2x squared is 3x squared. And then I'll bring down the other two terms. You notice the 0 placeholders don't actually change anything. They just line things up. Again, we look at first term of each side, what goes up on top. You ask yourself what times x to the third gives you negative 3x to the fourth. That'd be negative 3x. Whatever you put up on top, you multiply by what's out in front. Negative 3x times x to the third is negative 3x to the fourth. Negative 3x times 0x squared, negative 3 times 0 is 0. And x times x squared is x to the third. Negative 3x times 0x, negative 3 times 0 is 0, and x times x is x squared. And negative 3x times negative 2 gives us a positive 6x. We're going to subtract that line, which means flip signs. So plus, minus, minus, what, or minus. Negative 3x to the fourth plus 3x to the fourth drops away. 5x to the third minus 0x to the third is 5x to the third. 3x squared minus 0x squared is 3x squared. 0x minus 6x is negative 6x. And then I'll bring down the plus 0. Again, first term each side, what goes up on top? You ask yourself what times x to the third gives you 5x to the third. And that'd be 5. Whatever you put up on top, you multiply by what's up in front. 5 times x to the third is 5x to the third. 5 times 0x squared is 0x squared. 5 times 0x is 0x. And 5 times negative 2 is negative 10. We're going to subtract that line, which means we'll flip signs. So this becomes a negative, 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 positive. 5x third minus 5x third drops away. 3x squared minus 0x squared is 3x squared. Negative 6x minus 0x is negative 6x. 0 plus 10 is 10. Now you notice that this has a degree of 2. Degree is the largest power of x. This has a degree of 3. Since this is less, this is now our remainder. And so we put our remainder of what we're dividing by. So I got 3x squared minus 6x plus 10 over x to the third minus 2. And that's our answer. Questions on law and division? Yeah, they're more challenging. Now this is synthetic division. Law and division, usually not too important. You have some problems on it. But when you get to synthetic division, a huge part of the next test, the chapter 3 test, will be finding zeros. If you don't know how to do synthetic division, you're probably going to fail the test. It's a critical technique for understanding how to do the part of the process. So as I'm going through this example, if you don't understand it, be sure to ask. Let's see, x squared plus 3x minus 7 divided by x minus 2. So synthetic division. Our first step in synthetic division is you take what you're dividing by, you set it equal to 0. So we take the x minus 2, set it equal to 0, and solve it. And that gives us x equals 2. Then step 2, we're going to build a table here. You take whatever numbers that you found in step 1, you put it in the upper left-hand corner in a box. Now we identify our largest power. Our largest power is x squared. So real small, we're going to write x squared, we'll write x, and we'll write no x. Usually you don't want to make those big. If you make them big, then you'll mess it up. Some people don't need to write those once you learn the process. Then we write down whatever number's in front of each one of them. The number that's in front of our x squared is 1. The number that's in front of our x is a 3. Now when I say no x, I'm talking about the constant term. And our constant term is negative 7. We're going to go through a series of adding, multiplying over and over till we're done. I'll go slow at first, but then I'll pick up speed later on. First thing we want to do is add. So I'll start with our first column here. We got 1 and there's nothing here. 1 plus nothing is 1. Basically, you just bring that 1 down. But you got nothing to add. Then we want to multiply. You always multiply by the number up in the box by the number you just put down here. So 2 times 1 is 2, and you put it here. Then we want to add. 3 plus 2 is 5. Then we want to multiply. You always multiply by the number up in the box, by the number you put down here. 2 times 5 is 10. And then you want to add. Negative 7 plus 10 gives us 3. You're done when you don't have any more columns to work with. So now for our answer, this was x squared. This will be 1 degree lower always. So that'll be x to the first or x. This is our x. This will be our no x, or constant term. And this is going to be our remainder. So our answer is going to be x plus 5 plus 3 over what we're dividing by, which is x minus 2. Questions on that problem? Okay, let's take a look at the next one. X minus 2 that way. Next one is 2. Okay. Synthetic division. Take what you're dividing by, you set it equal to 0, and you solve it. So the -2 takes the right side, becomes a +2. Take your number you just found in step 1, you put it in a box in the upper left-hand corner. Our largest power is x squared, so real small, I'll write x squared, x, and no x. And we write down the numbers in front of each one. There's a 9 in front of the x squared, there's a -4 in front of the x, and -3 is our constant term, our no x. Then we'll go through a series of adding, multiplying over and over until we're done. Add, 9 plus nothing is 9. Multiply, you always multiply by a number up in the box, but number I put down here, 2 times 9 is 18. Add, -4 plus 18 is 14. Multiply, you always multiply by a number up in the box, by number you put down here, 2 times 14 is 28. And then add, -3 plus 28 is 25. Now this was x squared, so straight down below it will be 1 degree lower, that's x. And after you have your first one, you're going to have 1 for each power going down. So x, no x, and our remainder. So our answer is 9x plus 14 plus 25 over what we're dividing by, which is x minus 2. Okay, let's take a look at this one. I got a lot of x minus 2s for some reason. I tried to be random when I made those up, but I didn't realize I was using x minus 2 over and over. I guess I could use something else. X to the 4th. Plus x plus 2. And let me divide by x minus 5, just so we see something a little bit different. Step 1. Take what you're dividing by, set it equal to 0, and solve it. 5. Step 2, you build your form. Whatever number you find in step 1, you put in the upper left-hand corner. Identify our largest power, which is x to the 5th. So real small, across top of them, write x to the 5th, x to the 4th, x to the 3rd, x squared, x, and our constant term, no x. Then you write down the numbers in front of each one of them. There's a 1 in front of the x to the 5th. There's a 3 in front of the x to the 4th. There is no x to the 3rd, so you have to put a 0. So if you're missing any powers, then you have to put zeros for it. -4, 1, and 2. A lot of times when they teach you synthetic division in high school or intermediate algebra or something like that, they don't show you putting this across the top. If you put that across the top, it accomplishes 2 tasks. It makes sure that everything's in standard form, largest power down to smallest. It also ensures that if you're missing any powers, they're accounted for. Okay, so now we're going to go through and add and multiply over and over. 1 plus nothing is 1. Multiply, 5 times 1 is 5. Add, 3 plus 5 is 8. Multiply by the number in the box times the number down here. 5 times 8 is 40. Add, 0 plus 40 is 40. Multiply, 5 times 40 is 200. Add, -4 plus 200 is 196. 196. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. 1 + 2 = 4. Multiply. 5 times 196 is 980. Add. 1 plus 980 is 981. Multiply. 5 times 981 is 4905. Add. 2 plus 4905 is 4907. And we haven't got any more columns. Now this was x to fifth. This will be 1 degree lower. This is x to fourth. And then I have to have my first one. I have one for each power going down. X to third, x squared, x, our no x, and our remainder. We got x to the fourth plus 8x to the third plus 40x squared plus 196x plus 981 plus 4907 over what we're dividing by, which is x minus 5. And that's our answer. Pretty good so far? Let's take a look at number 7. X squared minus 5x minus 2x to the third plus x to the fourth divided by 3 plus x. Okay, first step. Take what we're dividing by, set equal to 0, and solve it. Here I take 3 over, and I get x equals negative 3. Step 2, build our form. The number you found in step 1, you put in the box in the upper left-hand corner. Identify your largest power, which is x to the fourth. So starting with x to the fourth, I'm going to have 1 for each power going down. X to the fourth, x to the third, x squared, x, and no x. Now I'm going to write down whatever numbers in front of each one. The x to the fourth, there's 1 in front of it, the invisible 1. The x to the third is negative 2. The x squared is 1. The x is negative 5. And there is no constant term, the no x. So I'll put a 0 there. Now add and multiply over and over. 1 plus nothing's 1. Multiply. Negative 3 times 1 is negative 3. Add. Negative 2, negative 3 is negative 5. Multiply, add, multiply, add, multiply, add. Now this was x to the fourth. This will be 1 degree lower, so that'll be x to the third. This will be x squared, x, no x, and our remainder. So our answer is going to be x to the third minus 5x squared plus 16x minus 53 plus our remainder of what we're dividing by, which would be x plus 3. And that'd be our answer. Okay, let's take a look at this problem. X to the fifth minus 32. divided by x minus 2. Okay, step 1, we take what we're dividing by, set it equal to 0, and solve it, which gives us our x equals 2. Step 2, we build our form. Our largest power is x to the 5th, so real small, I'm going to write x to the 5th, x to the 4th, x to the 3rd, x squared, x, and my no x. There's a 1 in front of the x to the 5th. There is no x to the 4th, so that's 0, no x to the 3rd, no x squared, no x. The no x, or constant term, is negative 32. Now I'm going to add and multiply over and over until I'm done. So 1 plus nothing is 1, 2 times 1 is 2, add, multiply, add, multiply, add, multiply, add, multiply, add. This was x to the 5th, so this will be 1 degree lower. That'll be x to the 4th. And then I'll have 1 for each power going down. X to the 3rd, x squared, x, no x, and this is a remainder. Our answer is x to the 4th plus 2x to the 3rd plus 4x squared plus 8x plus 16. And 0 is a remainder, so we don't need to put anything there. And that would be our answer. Now, that's probably not a bad place to stop. Now, remember, the Chapter 2 test is due this Wednesday. It says midnight, but that's really an hour early. So I know some of you have already taken it, but if you haven't, get started. Don't wait till last minute. Wait till last minute again. If the web is down on Wednesday, then I won't care. You'll get a 0 on it. If you're sick on Wednesday, I will not care. You've had at least a week to do the test, if not a little bit more. I don't remember when I put it out there, but it was last week sometime. So again, don't procrastinate. We're done.